Here we move on to some nomenclature questions, and we start in part A with a fairly straightforward question. This is one of our diacids, which we should know the names based on the number of carbons in between. So this compound has 4 carbons in between. If we remember our mnemonic, that gets us to our 5th of the diacids, which is adipic acid. Part B is a little bit more complicated. A lot more going on in this molecule. But the first piece, and what should be easy about this question, is that it's a carboxylic acid. What makes that make it easier is that tells us right here this has to be carbon number 1. And we can see fairly easily that we're going to be numbering it in this direction. So in total we have a 9 carbon molecule. And so we know this is going to be some sort of derivative of nonanoic acid. I'm going to start listing the substituents just so we have them listed all together. Carbon 2, we have a bromine. Carbon 2, we have a chlorine. We also have 2 cyclopropyl rings at 3 and 4. Of course, because there are 2 of them, we need to put the prefix di in front, so dicyclopropyl. At 5, as well as carbon 6, we have an alcohol group, but because we have the higher priority for the parent name from the carboxylic acid, we name those as substituents, so 5,6-dihydroxy. Same thing for the thiol group at carbon 9. We name that as a substituent, mercapto. And then we have a second chlorine at carbon 9. So we'll add that to our first one, and it becomes 2,9-dichloro. Right, now we need to take into account our stereochemistry. So at carbon 3, we have an alkene. Carbon 5, we have an alkene. Carbon 2 is chiral, and carbon 9 is chiral. So if we start with our alkene at carbon number 3, we have higher priority on this side from the carbon with the bromine and the chlorine versus the cyclopropyl ring. And then we have higher priority down here for the carbon bearing the oxygen. So given that those groups are on opposite sides, our alkene at carbon 3 will be E. At carbon 5, it's fairly straightforward because we have an oxygen, which will be higher priority than the carbon, and another oxygen, which will be higher priority than the carbon. Again, these are on opposite sides, and so 5 is also E. At carbon number 2, we need to figure out our stereochemistry. We know bromine, highest atomic number, will be first priority. Chlorine will be second. And then this carbon of the carboxylic acid, which has oxygens on it, will be higher priority than the carbon of the alkene because it only has carbons attached. So we have 1, 2, 3 as pictured there. We then need to rearrange this molecule, which we can't really do on paper, but we would need to rotate this molecule so that the lowest priority group, and the lowest priority group is this carbon group, is pointed back. We'll assume that we've done that. If you need help with that, you may want to pause the video right now and put this together with your model kit. Once you do that though, you'll see that the arrow goes counterclockwise, and carbon 2 is therefore S. Finally, at carbon 9, we have a chlorine, a thiol, and a carbon group. In this case, we don't have to rotate it. The lowest priority hydrogen is already pointing back. We know that chlorine is higher atomic number than sulfur, is higher atomic number than carbon. No adjustments need to be made. The arrow is clockwise, and so this is R. So at this point, we've figured out everything that we need, and now it's just a matter of putting it all together. So out at the front goes our stereochemistry: 2S, 3E, 5E, 9R. Remember, those always go in numerical order. Doesn't matter whether they're EZ or RS, we put them in numerical order. Then the substituents go alphabetically. So 2-bromo, 2,9-dichloro, 3,4-dicyclopropyl, 5,6-dihydroxy, 9-mercapto, and finally our parent name, nona. Alkenes come first, so it's 3,5-diene. Next is the alkyne, 7-ine, and then finally the carboxylic acid. And because the carboxylic acid is always carbon number 1, we don't need a number, so we can just end with oic acid.